EE1 answers. Number 1 is 6 to the 11th power. Number 8 is 5 to the 3rd power. Number 16 is choice D. Number 17 is the 3rd and the 4th choices. We'll call them C and D. Looking over at EE2, number 4, x is equal to positive or negative 7. Number 5 is choice A. Number 8, x is equal to 6. And number 13 is choice C. Okay, if you missed any of these, go ahead and watch this video and we're going to go over these in detail. Starting with number 1, we are multiplying like bases. The base is 6, and so we have all of these exponents, 6 to the 3rd times 6 to the 2nd times 6 to the 5th times 6 to the 1st. We're going to write our base, 6, and add the exponents, 3 plus 2 plus 5 plus 1. Since our rule says if we're multiplying like bases, we keep our base and add the exponents. Multiplication is just repeated addition. And so 3 plus 2 plus 5 plus 1 is 11. Looking on over to the next problem, number 8, very similar problem. We are once again multiplying like bases. So we're going to keep our base 5 and add the exponents. 2 plus 4 plus a negative 3, which 2 plus 4 is 6, plus negative 3 is 3. Looking at number 16, this one does look a little different. And one thing that I can point out that doesn't always stand out is when you have something like 1 over a number, we can actually rewrite that as that denominator 5, which was to the 1st power, is now negative 1, and this is raised to the negative 2nd power. So I'm going to go through and use my exponent rule, which says when I have a power raised to a power, I'm going to multiply the exponents. And so I get 5 to the 2nd power here. Let me bring down the rest of this. We get times 5 to the 3rd power divided by 5 to the 7th power. And so 5 to the 2nd times 5 to the 3rd power, we're going to keep our base 5 and add the exponents 2 plus 3, which is 5. And then I'm going to divide by 5 to the 7th power, which is equivalent to 5 to the 5th minus 7, because when we're dividing like bases, we subtract the exponents. The result is 5 to the negative 2nd power. That's the same thing as 1 over 5, to the positive 2nd power when it crosses the fraction line, which is 1 over 25. Number 17 is a similar problem and go through it a little more quickly. We are dividing like bases on the first choice, so we're going to keep the base. 7 minus negative 2 is like saying 7 plus 2, which is 9. Is that equal to 6 to the 5th power? No. The next choice, anything to the 0 power is 1. Is that equal to 6 to the 1st power? No. The next choice, 5 to the negative 1st times 5 to the negative 1st power. I could work this different ways, but if I keep my base 5 and add my exponents, I get 5 to the negative 2nd power, which is 1 over 5 squared, which is 25. And then 25 to the negative 1st power is 1 over 25 to the 1st power. These are equal. In our next choice, we have 8 to the 0 power times 8 to the 3rd power. We add our exponents, which gives us 8 to the 3rd power. Is that equal to 8 to the 3rd power? Yes. And then our last choice, we are dividing like bases, 4 to the negative third power divided by 4 squared. So we take our exponents and subtract. We get 4 to the negative fifth power. Is that equal to 4 to the positive fifth power? No. EE.2 number 4. We have x squared equal 49, and we're just solving a little equation. We're going to undo squaring x by doing its inverse, which is taking the square root. So the square root of x squared is x. And when we take the square root of 49, our calculator will say 7, but since it's a square root, we could get a positive or a negative 7. Anytime you have a square root, it's either a positive or a negative. There's 2 possible roots. We often just deal with positives because we're dealing with positive numbers. Number 5, which one is irrational? Well, the second one equals 2. The third one equals 2. The last one equals 4. Square root of 2 is the only one that is a non-terminating, non-repeating decimal when you change it to decimal form. Number 8. We're going to solve this equation. We have x equal the cube root of 216. In fact, it's already got x by itself, which makes this simple. We're going to go to a calculator, type in cube root of 216, and we get 6, simply by using our calculator. And then the last one, number 13, the perimeter of a square is 20 feet. What is the area? Well, it gives us the perimeter, and we have to think about what these words mean. The perimeter, it's a square, so it has equal sides. There's 4 equal sides. Perimeter is distance around it. So if the perimeter is 20 feet, well, that means that we can take that 20 and divide by 4 to get 5 feet, which is the measure of each side. Now, I want to know the area. The area of a square is the side squared. You could also say that it's length times width or base times height, but length and width are both 5. So we get 5 squared, which is 25.